So I think boundary conditions are one of the most intuitive things in RAS 2025. They work an awful lot like you would expect them to work if you are familiar with the RAS 6 series, but there are a couple of paradigm shifts that I think are going to be pretty useful for you to know about to make the transition go smoothly. So I'm just going to tell you a little bit about how boundary conditions are different in 2025 and then show you how to add them. So if you're familiar with boundary conditions in the RAS 6 series, we're going to go to our unsteady boundary conditions here. And then if we open up that boundary condition, this is basically how you would define a boundary condition. You have a boundary condition editor that has everything you want in there, and then each of these boundary conditions has its own editor. And there are two time windows that you're going to deal with. One is that the actual boundary condition itself has some start time information. You can inherit it from the plan, but I usually don't. I usually go in and assign the actual fixed start time with this so that the time window can kind of shift over it for the plan. And then you go into the plan, and the plan has a time window for the simulation. The thing that doesn't have a time window is the boundary condition itself. The boundary condition is kind of temporally naive. You can have all of these different boundary conditions in it that all have their different start times, and then the plan window will go and decide where it's going to run over those start times. And if one of them doesn't happen to have data over there, well, we'll give you a helpful error message. That is not exactly the way things work in RAS 2025. And there's some real advantages, particularly in precipitation. We designed this with just flow in mind, but now, we can move into rain on grid and all of that, and RAS 2025 is going to have that very early. And so there are some things that kind of we wish worked differently when we move into the rain on grid world that's going to require a little bit of a paradigm shift here. And that big paradigm shift is that the boundary condition itself is going to have a time window. And so there's actually going to be 3 time windows. You're going to define the start time here the same way you would, or inherit the boundary condition start time. And then the plan is still going to have a time window, but in general, that's just going to inherit from the boundary condition time window. So all we're really doing is taking this time window and pushing it down to the boundary condition. But you're going to be asked for a time window sooner in RAS 2025 than you were in the legacy series. So we just kind of want to prepare you for that. Okay, so let's go actually put in a boundary condition. And there are a couple of things about how this is going to work in 2025 that'll be quirky for a little while, and we'll just kind of talk you through those. Okay, so I have my conceptual mesh, and this is a tributary, and so I'm going to want to have a main flow boundary condition here, some sort of stage boundary condition downstream, and then a tributary flow. The first difference that you'll notice between RAS 2025 and Mapper is that you're not actually going to define your boundary conditions spatially in your geometry. They never really belonged in the geometry anyways. We've always wanted to do this. Boundary conditions are going to exist on their own and be spatially referenced on their own. So let's go and create a new boundary condition, and let's call it demo. And this is what I was talking about. This is a very early ask for your simulation time window. In these kind of early alpha releases, you're actually going to have to fill this time window. All of your boundary conditions are going to have to completely fill this time window, and then your plan can go in and sample parts of it. Later, it'll be more flexible, but I know that this event started in April 10, 2019, and you'll notice that the way we're putting in dates is more flexible than it used to be, and we'll just start at that 000, which is midnight the night before, and we can use the picker here as well, so we'll go for 12 2019 and say yes, and then we'll just go from midnight to midnight. So it's a 2-day time window. All right. And so then we have our boundary condition, but now we have to go in and put in our kind of geospatial representation of the boundary conditions. And so we're going to call these boundary condition lines, and now we'll get our helpful drawing tool back. And so we'll go in and draw our boundary condition lines, and we'll put one right here. Remember, you always double click to start. That'll take some getting used to. And now we have this little question mark because it's like, hey, what do you want? We don't know yet. But let me just go define them all first. So then I want another one here. And then I want it downstream. And I'm pressing shift in order to pan even though I'm in edit mode. Okay, so I have my 3 boundary conditions lines. I've spatially georeferenced them. Let's start with this one first, because this one's easy. So if you click on it gives you the three options. It gives you a stage option, which can be a stage time series or a constant. Any of these, there's much more flexibility. They can be constant or they can be time series or other things, a flow or a normal depth. And so this is a flow, and it's actually a constant flow. So I'm going to come in here, and instead of tabular, I'm going to choose constant. And that is going to collapse the whole editor so that I can just go in here and say, hey, give me a constant of 50 CFS. Okay, so that's pretty simple. So then I'm going to go down and do the other easy one, and that's going to be normal depth. So I'll select normal depth, and of course normal depth, you're just back calculating a stage out of the Manning's equation, and we have everything you need for the Manning's equation with one exception. We need the friction slope, and a good approximation for the friction slope is the bed slope through the area, and we're going to call this 001. Okay, so those are pretty easy. Let's go look at something a little bit more complicated though. Let's go actually add an event up into this upstream boundary condition, and so we'll say flow. And I also want to say probably like 50 to 60% of the bugs that we've found in RAS 2025 in the last 2 months have been in this editor. We're using kind of a standard Microsoft widget right now while writing our own. Zach and Alex are writing something that's going to be better, but for now we're using this kind of off-the-shelf technology, and it's got some quirks. So this is all hopefully going to improve quite a bit. But for now, it totally does the job. So here you put in your starting time, and it just kind of inherits the starting time from the boundary condition window. And so in some ways, as long as you're inheriting the starting time both ways, you actually only have to put in your time once. And then you've got all of these multipliers and minimum flows that goes and looks at the energy slope. And then we're going to come in here and we're going to clear all this because I'm going to interpolate. But the first thing that you want to do in a RAS model is what? Well, you're going to have to initialize it or warm it up. Remember, RAS 2D subgrid technology starts out dry, and so you have to run a certain amount of warm-up time in order to fill up the model before you actually start your simulation. We don't have any sort of warm-up technology in there right now. It's a high priority. It'll be out before the beta version. But for now, if you want to run a model, you actually have to warm it up yourself. And so what we're going to do is the first 12 hours of this model, we're going to run as base flow. All right, and so we'll just run that 300 base flow in order to warm up the model, and we'll actually start the model at noon on April 10th. Okay, but then we're going to ramp it up. We have an event that kind of ramps up from 3,000 to 6,000 over the course of 12 hours. And then over the course of the following 24, it'll drop to 600. And then we'll go in and we'll interpolate to get our hydrograph. And so now we have all our boundary conditions. And of course, what you're going to be looking for next is some way to plot that. And again, all of the what we call the charting tools, all the 2D plots, that's all still kind of coming, but there is kind of rudimentary way of looking at this. Right now we're kind of looking at everything in this layer here, but you can actually pop this whole thing out and you can say open editor, and that will create an editor that you can either dock or look at independently. And this has most of the same data that you would be interested in, except if you press this, you will actually get a plot of your data. And so you can go in and evaluate, does this look like how I expect it to look? And we have our 3 boundary conditions here, but of course, constant and normal depth don't get plotted. All right, so that's really all that I needed to show you about the boundary conditions, but actually let's go and run this thing because why not? And so we'll come in and we'll make a plan and we'll call it boundary condition demo. And then we have to put in another time window. Well, that's a drag, except that what we could do is we can just come in and say we want to adopt the boundary condition time window. Then we just leave that blank. Of course, we have to select a geometry, and we'll select our boundary condition and create. And now our plan shows up over here. Of course, you've probably figured this out by now. You can come over here and you can open the editor and you can get a plan editor if you want it. But I just like it over in the side panel over here. And if you're an experienced RAS user, you would think, well, the first thing I want to do is come over here and change the computation interval. And you can. The thing that you need to know is that, previously I said that these are the same computations, and they are, except that we're using an explicit solver. The explicit solver has the opportunity to parallelize a lot better. The explicit solver does open up the opportunity for us to move into the GPU direction. The explicit solver is also what we call Courant limited, which means that this time step is more of a suggestion. What RAS will do is RAS will actually go in and determine the time step it needs to run the model. We'll have more information about that, but it's just something that's worth knowing. And so I'm going to go and press the compute button, and you can see that we are running. If you go up into tasks, it'll show you what's going on and where we are in the compute. We got a lot of feedback that we really needed to keep the running person branding, and so Zach took that charge to heart. And of course, one of the big differences with RAS 2025 is that this is still running right here, but if we come in here and we look at the depth, you can start looking at results immediately. You don't have to wait until it's done. And so you can see that like early in the simulation, we are basically just filling up the model. We need to run those first few hours in order to just warm it up. And you have to do that manually in your time series. At this point, I just went in and put in those first 12 hours. But eventually we will have all those warm-up features. And then, you'll go through and have your rising and falling height graph. You can look at your velocity. And that's introduction to boundary conditions in RAS 2025.